Hi everyone. Hello. Hi. I hope I'm audible to everyone, guys. Yes. Is it audible to everyone, guys? Please respond in the chat box if it is audible to all. Actually, sorry everyone. Actually, I was facing some technical issues from last half an hour. Actually, that's why I couldn't start the class at the time. Yes, actually, yeah. Actually, it's always started at the time, on time of the class. I'm sorry, actually, I was facing some issues from my side. Extremely sorry to all of you. Guys, thank you for your time. Okay. You are waiting for me, and that is actually I'm feeling sorry for it. Yeah. Mm, Same thing is happening actually. With my pen and there is some problem. Just a minute. Okay, sure. So, yes, actually today we're going to start our new chapter, that is binomial theorem. Okay, and in the previous week we have completed the topic, that is sequences and series, right? So today we'll continue with binomial theorem, right? Let's see. So what is binomial? An algebraic expression which is containing two dissimilar terms is called binomial. Okay, so let's see. See here, you have some examples of binomial. Like here you have two terms in these expressions, a plus b. A and b are two terms in this expression. Okay, so why that's why these terms are called actually binomial. Yeah. Yes, actually, I'm actually really sorry, YouTube guys. I was facing some issues, technical issues from last half an hour. Actually, I was struggling with my pen tab. That was actually not working. That's why I'm very sorry to all of you. You wait for the class. Thank you all. Then let's see. Huh? Then this is about binomial, and now we'll learn what is Pascal triangle, right? So what is Pascal triangle actually? Hmm? So this is actually Pascal triangle is a very lengthy method to find the coefficient of an expansion. Okay, so Pascal triangle can be used in determine the coefficient of in binomial expansion. So before going through the binomial expansions, actually, before going through the binomial theorem, now we'll see how to find the coefficient of binomial expansion by using the Pascal triangle, right? Okay, so it's a lengthy process. Hence, in generally, we can say when we'll expand the term, when we'll expand the binomial expansions like a plus b to the power n. Okay, so without writing all terms of Pascal triangle, triangle is required. Okay, so let's see what is actually Pascal triangle. Pascal triangle actually looks like this type. See, so this is my Pascal triangle. So this looks like a triangle or not? Yes or no? So how we can find the coefficient of binomial expansions. Suppose I'm taking one example here. I'm taking one blank page, then we can understand. Okay. Here, suppose I'm taking the binomial term expressions like a plus b to the power g, like a plus b to the power 0. Okay, so for this we have only two terms in this expansions. Yes or no? A and b. Okay, so what are the coefficients of a and b here? One only. This is actually one, na? So a plus b is equal to 0. A plus b to the power 0 is equal to 1. So 1 is only one term in this binomial expansions, and the coefficient of 1 is 1. So that's why I'm writing 1. Okay, so Pascal triangle, like then we can further proceed with write in this way, write 1 here. Okay, similarly write here a plus b whole square. So if we'll open this, we can write this as a square. Oh, sorry. We'll go through first a plus b to the power n. Okay, sorry, 1. So this is equal to a plus b. So the coefficient of a is 1 here. I have written here, and the coefficient b is also written here 1. So that's why I have written in this way. Okay, now again write, start with 1, and here also write 1. Then add these two ones, this and this. This is 1 plus 1, and write here, that is 2. Now try to write a plus b whole square. That is, the terms will be coming as a square plus a square. I'm writing all the unknown terms first. A square plus ab, sorry, a square, ab, and b square. Now write all the coefficients. So coefficients are 1, 2, 1, right? So write here 1 into a square plus 2 into ab plus 1 into b square. Now see, the expansion a plus b to the power 2 is a square plus 2ab plus b square. Similarly, we can write, we can process further process also. That is 1 right here. Again write 1 here, right? So then add 1 plus 2. Now add these two terms and write here. That is 3. Add these two terms and write here. That is 3. So now you know the formula for a plus b to the power 3. Yes or no? That is a cube. First write all the terms without coefficient. A cube. First is a cube. Then reduce or subtract or reduce 1 power of a. That is a square into b. A square into b. So power sum of powers of a square and b is 3 always. The term, what are the terms in the binomial expansions you will be having? The sum of powers of the term will be always equal to the power present in the expansions. Okay, that is a square b. Then again reduce 1 or again subtract 1 from the power of a, that is a, then b square, then write b cube. So now write all the coefficients. First coefficient is 1 into a cube plus 3 into a square b plus 3 into ab square plus b cube, that is 1. So you got the expansion a plus b to the power 3. Okay. Similarly, if I'll ask you to write the expansion of a plus b to the power 4, then what it will be? A plus b to the power 4. Then same process, follow the same process, that is 1 here, right? 1 right here. Okay. Now add these two terms. This is 4. Add these two terms, that is 6. Add these two terms, that is 4. So the binomial coefficients will be 1, 4, 6, 4, 1, right? So that is 1 into a to the power 4 plus 4 into subtract 1 from the power of a, that is a cube, into b, start with b, plus 6 into subtract 1 from the power of a, that is a square, into add 1 with the power of b, that is b square, plus 4 into a into b to the power 3, a into b to the power 3, again subtract power of 1 from the power of a, plus 1 into a b to the power 4. So this is the expansion of a plus b to the power 4. Okay, so in this way, by using the Pascal triangles, we can expand all the binomial expansions, right? Okay, but it's a very lengthy process. If I'll ask you to find the expansion of a plus b to the power 100 by using Pascal triangle, so it will be actually it will be difficult to expand a plus b to the power 100 by using the Pascal triangles practically, without using the computer programming. Yes or no? Is it or not? Clear? So this is all about your Pascal triangle. Clear, everyone? Okay. So if it is clear to all, then now move through our next thing, that is factorial notation. So in today's class, actually we got only 15 minutes, and that's actually it's my fault. It was my fault actually. I was facing some technical issues. That's why I didn't started the class at the time, on the time. Okay. So really sorry for that. Okay. We'll just overview or go through the overall, go through the basic concepts. What are the concepts we are going to use in binomial theorems, and we'll try to complete all the concepts and with some previous JEE questions in this week of binomial theorem. So what is factorial notation? All of you know about in permutation and combination. The product of first n natural number is denoted by n factorial. It is factorial of n factorial is the product of first n natural numbers, and you know, all of you, n factorial is 1 into 2 into 3 into 4 into up to n minus 1 into n. Okay, and already we define 0 factorial as 1. All of you know 0 factorial is always 1, and n factorial is n into n minus 1 factorial, and it can be also written as n into n minus 1 into n minus 2 factorial, and so on. So all of you know all these things. Okay, so let's move to the next thing now. NCR. Okay, so formula for combination. All of you know what is the formula for combination? Yes or no? So that is NCR is equal to n factorial upon r factorial into n minus r factorial. Yes or no? All of you know, na? So that is that means it can be written also, it can be denoted by a C of NR and A से भी हम लिख सकते हैं ना, C of NR, it can be represented by this also, and also this can be written as NCR. Okay, so this means actually what we are doing here, we are selecting or we are getting the combinations, the set of all combinations, or we can say we are selecting R objects out of N objects. Combinations means basically it is selecting the objects, right? So NCR means selecting R objects out of N objects. Is it or not? Where R must be always lying between 0 and N, and N belongs to the set of all natural numbers. Is it clear to all? Okay, so all we'll go through some formulae. First formula, all of you know these things. NC0 is 1 always. Remember, NC0 is 1, and N is always N 1. NC0, the value of NC0 is 1. N is 1. All of you know these things. Let's move to some other formula. NCR is equal to actually N factorial upon R factorial upon N minus R factorial. Okay, where R is lying between 0 and N belongs to set of all natural numbers, and R must be a whole. Right? This is the first. This is second. Okay, so NCR. Remember, this is important formula. NCR is equal to NC N minus R. Remember this formula, NCR is equal to always NC N minus R. Suppose I can say 3C2 is equal to 3C1. That is 3 minus 2. Is it clear to all, guys? Yes. Clear? Okay. So third formula is clear to all. So NCR is equal to NC N minus R. Okay. And the fourth one is NCR is equal to NCS. When we can say NCR is equal to NCS, when R is equal to S, either R is equal to S, or we can say N is equal to R plus S. These two possibilities will get when we'll say NCR is equal to NCS, then either R is equal to S or N is equal to R plus S. Okay, guys, clear? So let's move. Fifth formula is saying NCR plus NCR minus 1 is actually N plus 1 CR. Clear? N plus 1 CR. Right? And sixth formula is NCR is equal to NCR minus 1. NCR minus 1 is equal to actually N minus R plus 1 CR. Right? N minus R. Okay. See, this is the formula. Guys, this is the what is the seventh formula? I'm writing it properly. NCR upon NCR minus 1 is equal to N minus R plus 1 by, if you elaborate it, okay, this is N minus R plus 1 by R factorial. Okay, R factorial. Let's calculate it and solve this one. Okay, this will be this will not be factorial. Let's check it again. Okay, sure. So NCR will be N factorial upon R factorial into N minus R factorial, and this will be N factorial upon R minus 1 factorial into N minus, sorry, R minus 1 factorial into N minus R plus 1 factorial. So calculate this and you will get this n minus r plus 1 by r factor r. Okay. So this is the formula actually. Okay. So NCR is equal to n by r. Remember, NCR is equal to n by r into n minus 1 CR minus 1. So these are all formula you need to remember to solve when it will be used. It will be used actually when you will be solving questions. Then it will be very much useful in problem solving. Okay. So from some note here actually, what is the working rule for NCR? That is n into n minus 1 into n minus 2 up to n minus r plus 1 divided by r factorial. Okay. So this is the working rule for NCR, right? Okay. So this is all about your factorial notation for or formula for factorial notation or formula for combinations. Okay, so this is the first JEE mains questions came in 2022. So actually, what are the concepts we covered? Now, what are the concepts we covered? By just use the formula of combinations and try to solve these questions as your homework. And let's take this question as your homework because it's time actually. You have another class also in this time. So I need to stop here and we'll start from these questions in the next class. Day after tomorrow, tomorrow we have no class now. So from Thursday we'll start from these questions and also we'll try to cover the binomial theorem in the next class and we'll solve how to find the general term of binomial theorem and also we'll solve some previous JEE mains questions came in 2022 and also in 23. Right. So what is the approach to solve these questions? Anyone can say what is the approach to solve these questions? So 40C0, just use all the formula. So use the formula previously I told you. Those formula will be used to solve these questions. So this is, it is given that 40C0 plus 41C1 plus 42C2 up to 60 C20 is equal to m by n into 60 C20. Just take m and n are co-prime, then you need to find the value of m plus n. Anyone got the answer? Anyone got the answer for these questions? Guys, anyone got the answer for this question? Yes. So can we say 40C0 and 41C1 41C1 and 40C0. Can we write this as we know now one formula, that is NCR is equal to n plus 1 C n minus r. Is some, so in place of 40C0 we can write this as 41C 0 or not? Sorry, this is n minus r. I think wrote it wrongly actually. Yeah. This is 40C0 is equal to, what is the formula we used here? That is NCR is equal to NC n minus r. Yes or no? Or we can say NCR plus NCR minus 1 is equal to n plus 1 CR. N plus this formula. NCR is plus NCR minus 1 is equal to n plus 1 CR. Use these two formulae to get the answer. So 40C0 can be written as 41C0 or not? Yes. So and all the terms, rest of the terms, keep rest of the terms as same as. Okay. So that is 42C2 up to 60C20. Similarly, you can see here 41C0 plus 41C1. 41C0 and 41C1. Use this formula. And what you will get, that is 42C1 or not? 42C1, use this formula. plus this is 42C2 up to 60C20. So similarly here also we can write 43C2 plus 44C3 up to 60C20. Yes or no? So if you'll go through in this way only, so what you will get actually in finally we'll get what you will get 60. What you are having actually we'll get 60C20 and finally we'll get 60C20. Before this term we are having 60C19 plus 60C20, which is equal to actually 61C20. Yes or no? So 61C20 we are getting, which is given as m by n 60C20. Okay, xy 60C20. So in the left hand side we are getting 61C20, and in the right hand side we are having m by n 60C20. Right? If we'll use the formula to find the answer, let's see here. Here, left hand side, we got 61C20 is equal to m by n 60C20. If we'll use the formula of combination, this will be 61 factorial upon 20 factorial into 61 minus 20 factorial is equal to m by n into 60 factorial upon 20 factorial into 60 minus 20 factorial. Is it or not? Now you can see, you can cancel out from both the sides 20 factorial and 20 factorials, and here 60 factorials and 61 factorial. Okay, 61 upon 61 upon will get 41 factorial is equal to m by n. This will be 1 upon 40 factorial. Yes, so it will be cancelled out and we'll get 61 by 41 is equal to m by n. So m, we are getting m by n as 61 by 41. So m plus n will be 61 plus 41. That is 102. So the correct answer is 102 for the last question we have taken. Okay, so from the very basic concepts also, the questions are coming in JEE mains examinations. Is that clear, everyone? So if you know the basic concepts, you can solve the questions of mains level. Okay, so now you can see what is the answer. That is 102. What we did actually, we used the formula what we have discussed previously. So that is 40C0 plus 41C1. 40C0 can be written as 41C0 also. 40C0 can be written as 41C0. Yes or no? And 41 and rest of the term we have written as it is. Okay. Then 41C0 plus 41C1. These two terms, if sum of these two terms by using this formula, we can write 42C1. Similarly, after this, we have 42C2 up to 60C20. So similarly, add these two terms by using this formula, we'll get 43C2. So if we'll be doing similarly for all the terms, finally we'll be having 60C19 plus 60C20. So which will be coming out as 61C20, and 61C20 is actually m by n into 60C20. Okay, and now then we use the formula of combinations, and after calculation or after use the formula of combinations, we got the value of m as 61 and n as 41. So m plus n is in 102. Right, guys? Okay, so this is all about your first questions we have discussed. In the next class, we will be starting from binomial theorem. Okay, guys? So thank you all. Bye bye. Take care, everyone. Because it's time to end here the class. So in the next class, we'll be starting from binomial theorem. Okay, thank you. I was very sorry. I am extremely sorry for the delay. of the class. We have started the class lately. That's why I'm actually really extremely sorry. We'll be starting the class on time always. We have already started. We have started always the class on time, or before the time also we have started the class. So today we have faced some issues. So that's why actually I really very sorry. So thank you all. Thanks for your time. Thanks for your patience. Thank you. Bye bye. Take care.